Phase modulation is a modulation pattern that encodes information as variation in the instantaneous phase of a carrier wave. Phase modulation is widely used for transmitting radio wave. Phase modulation is closely related to FM, frequency modulation. Phase modulation also used for signal and waveform generation in digital synthesizer. Okay.
Frequency modulation, or FM, is the encoding of information in a carrier wave by varying the instantaneous frequency of the wave. This differs with amplitude modulation, or AM, in which amplitude modulation varies the carrier wave, but the frequency will stay the same. FM is widely used because it has a better noise tolerance rather than AM. The application of FM is in radio broadcasting, telemetry, radar, two-way radio systems, and many more.
Amplitude modulation is the process when the amplitude of high-frequency carrier wave is changed in accordance with the intensity of the signal. In amplitude modulations, only the amplitude of the carrier wave is changed. The phase and the frequency of the carrier wave remains constant. This modulating sine wave signal shows the principle of amplitude modulations. It also shows that the audio electrical signal of frequency, also known as Fs. This is the carrier signal with constant amplitude frequency. The frequency is known as Fc. The amplitude modulated wave is not that the amplitude of both positive and also negative these positive and negative half cycles of carrier wave are changed in accordance with the signal. Thus, the amplitude of the modulated wave pulls the frequency of the audio signal wave. There are advantages and disadvantages of amplitude modulations, also known as AM. Although it is easy to implement, but the signal is not efficient in terms of bandwidth and power use.
Difference for amplitude modulation, carrier wave is modulated in amplitude by the signal that is to be transmitted by the amplitude. And then for frequency modulation, it's modulated in frequency, and phase, of course, is in phase. Then for amplitude modulation, frequency and phase remain the same, and for the rest of and for the other two, frequency and phase modulation, amplitude remains the same. But for frequency modulation, instantaneous frequency varies with the signal, and for phase, instantaneous phase vary with the signal also. Next, for complexity, AM wave transmitter and receiver are simple, but synchronization is needed for single sideband suppressed carrier. And then for FM and PM, transmitter and receiver are more complex. Variation of modulating signal has to be converted and detected at the transmitter and the receiver. And then for noise, amplitude modulation is more likely to be influenced by noise. Noise will affect amplitude, which is where the information is stored in amplitude modulation, and then it's less likely to be influenced by noise for frequency modulation and phase modulation, because information of FM and PM is stored in frequency and phase. So noise that affect amplitude is not likely to be affecting FM and PM.